Hello, welcome to ANS Solver. This is the fifth question of the paper. As you can see, there's a manufacturer that claims that 10% of the packets, include a free offer printed. So Jyoti suspects that the true proportion is less than 10%. So he plans to, test it by taking 40 randomly chosen packets, and he says that the offer that it's less than 2. So now state a suitable hypothesis for the test. So simply we need to state the null hypothesis, which basically states that my probability is equal to 0.1, and my alternative hypothesis, which is the counterclaim, which states that it's less than 10%. So it's less than 0.1. Now I need to calculate the probability of a type 1 error. Okay, so now what I need to do is, a type 1 error basically means the probability of rejecting H null or the null hypothesis, but the null hypothesis is false. So I can basically say the probability of the critical region. The critical region basically means from the region from where the rejection starts. So the rejection starts mainly from if the number which is included in the offer is less than 2. So basically the probability of x being less than 2. Okay. So now if you see, you have 40 here and 0.1 here. So what you need to do is, you have a binomial, with a mean of, or the number of 40 comma 0.1, which is n comma p. So what I need to do is basically because I need it less than 2, I need the probability of x equals to 0 plus the probability of x equals to 1. Okay, that means it's less than 2, correct? So for less than 0, what I need to do is, I need to do 40 c 0 into 0.1 raised to 0 into 1 minus 0.1 raised to 40 minus 0, plus I can write this as 40c1 into 0.1 raised to 1 into 1 minus 0.1 raised to 40 minus 1, which is 39. So you can simply use your calci to solve something like this. So yeah, even I'll use my calci. Just give me 1 second. I'll get you your answer. And even you can try till then if you want. Yeah. Okay, it's simple. It's a simple, question to solve. Not much has been asked here till now. Okay. So now it's basically the summation from 0 to 1. So yeah. So the answer I get is simply 0.0805, which is the probability of a type 1 error. So yeah. Now, on another occasion, Jyoti looks at 80 randomly selected packets from where exactly 6 include the free offer. So we need to calculate approximate 90% confidence interval for the proportion, this being the keyword, that include the offer. So because they have used the word proportion, there's an important concept which comes here called as the population proportion or the probability of success concept. So here it's stated that the mean is basically the probability of success, and the standard deviation is basically the root of p into q, which is basically 1 minus p, because q is the probability of failure and p is the probability of success, over n. So I know I got 6 out of 80 here. So this is basically 6 out of 80, which is equal to 6 over 80, which gives me 0.075. So now for my standard deviation, I can simply do the square root of 0.075 into 1 minus 0.075 over n, I know n is basically 80 because I've taken 80 packets. So now I can use my calci to solve this. So when I solve it, the answer I get is simply 0.02944. So now I need a 90% confidence interval. So what I need to do is basically, let's say this is my normal distribution curve, okay? Because it's a 90% confidence interval, I know the area in between is 0.9 because 90 over 100 is 0.9. So now what I need is, I know the area here is 0.05 and the area here is 0.05. Okay, this is what I know. So I can simply state that if I want, I need the two z values, the upper z value and the lower z value. If I want the upper z value, I do 0.9 plus 0.05 to get 0.95. Okay, so the z value for this, I'll go up here. So see, it's already marked because in one of the question also we did 0.95. So the z value for that is 1.645. Okay. So I get 1.645 here. And as it's the same area 0.05 and 0.05, this is minus 1.645. So now I know a formula that the upper z value is equal to the upper x value minus the mean over the standard deviation over root n. Okay, this is what I know. So now actually there's no root n here. It's just basically the square root of pq by n, which we calculated here. So now my z upper value is 1.645, which is equal to the x upper minus the mean. I know my mean is 0.075 over 0.02944. So now I can simply calculate for the x upper value here. So I'll do 1.645 into 0.02944. So I get this plus 0.075, where I get 0.123 here as my upper value. And here in my lower value, I get this as x lower minus the mean over, actually this is not the mean, this is the p basically, because your mean is p over pq by n square root. So I get minus 1.645, which is equal to the x lower value minus 0.075 over 0.02944. So now I can solve this also on the calci. So yeah, when I solve this and I add 0.075 to it, the value I get is simply 0.0266. So now my confidence interval is always written by my lower limit, comma my upper limit. So I can write this as 0.0266, comma 0.123. So this is basically the final answer of my question. Now, use your confidence interval to comment on the manufacturer's claim. So the manufacturer claimed that 10% of the packets include a free offer. So 10% is basically 0.1. So if you see 0.1 lies in between the confidence interval, that means the manufacturer's claim is not wrong, as 0.1 is within the confidence interval.